Hello everyone and welcome back to the series of our trees. जैसा कि मैंने कहा था यार recursion is over. मैंने यहाँ सारे links डाल रखे हैं. The links are mentioned here. You can see all the questions here and you can have this link. You can click on this link and visit to the previous videos, right? So as we have taken the initiative of completing the playlist first of recursion trees, graphs and DP. So let us start with the first video of the trees here. And first episode and the first episode will be on the introduction and application, that why and what are trees are required, let's say. And let us get back to the paint section and let me write some few things for you, that what is trees, what is the requirement. So tree is nothing but a data structure, right? And you must have uh, come across this structure, which is, let's say, have this as a root node and then it has some branches, right? So let's say this particular root node has just two branches. So let's say that the right branch has the value as 40 and the right as the 50, right? So this is something we call as a tree structure, right? Because it has a branches. There is a root node and it has some branches. So I have shown only two, but that's not the case. You can do much more, right? And if you have just two branches, then it is known as binary tree, right? Binary tree. At most two branches. At most two branches means it will have, let's say, 0, 1 or 2, but not greater than 2. And if you have exactly 26 branches, then it is known as a tri-data structure. We will discuss this thing after in our future lectures, future episodes. So let us get familiar with some of the terminologies that is involved in root. So there is one terminology known as root node or root. So these both are same. Then there is another word that is leaf. Then there is another word that is child, parent, ancestors, descendants. Then there is something called height of the tree. Then there is degree, degree of the tree, right? And then there are internal nodes. Okay, so let us discuss the one by one the each term, and then we will jump on a quick demo, quick code, which we'll see and how the tree is functioning, right? Okay, so node and root are nothing. This is the same. The first node, the starting part of the tree is known as a root node. Leaf node is the last nodes which are known. The bottom nodes are known as the leaf nodes. Anything in the between is known as the internal node. So let's say we have the structure like this: 2, 4, and 5, and then goes as 40, and then goes as 50, right? So these two nodes are the leaf nodes. These two are the internal nodes, and this is the root node, right? So we have discussed root, node, leaf, child, parent. So what is parent? So what if I told you, if I ask you who is the parent of 40, right? Like who is pointing towards 40, right? Just the above node. So we will go one level above from the 40 and we will see that 2 is having a branch towards 40, right? So I will say that 2 is the parent node of 40. What is the ancestors? So suppose if I'm at this level, if I'm at this level, my current level, then all the nodes above this level will be the ancestors and all the nodes below this level will be the descendants, right? Height of the tree. So what is the height of the tree? This is, let's say, level 1. This is level 2, right? So height of the tree will be 2, right? Okay. Okay. So there are few more terminologies, that is degree. So degree is nothing but in degree and out degree, right? So degree is nothing but how many points are pointing, lines are pointing towards the this thing, right? 4. That's known as the degree. So here you can just see that only one branch is. Suppose there were another node, let's say 3, which was also pointing to this, right? Which is also pointing to this. Then you will say that the degree of 4 is 2. But that's not the case, right? In tree, in tree we only have this thing: a right child and a left child. Okay. Then goes the internal nodes. We already explained. Then there are some types of trees. We will discuss that in next lecture maybe. The types of trees. We'll start with the next lecture with that. And let's build a tree, because theory mm, theory is always in the paper. You can read in any book, but to understand that how the code is working, how the flow is working, right? Then we will be able to have a complete good understanding, right? So I was always saying that node, and node, right? So let's make a class node. Uh, if you're coding in Java, then you must know what a class represents, right? We have a class node, then we will declare some structures, some parameters in this, because when you come to this node 2, right, you see that the type of this is node. We are saying we are declaring this type as node, because in Java, in any programming language, you have a data type as like int, float, string, and everything, right? But this particular thing we are making it, right? This is a man-made structure. We are making it, right? This is not built in. Yeah, correct word would be it's not a built-in, right? We will define it and name it as node, right? And to make a structure, we have to use this class keyword. So class node, so what it has a left pointer, right pointer, and a data in itself. So left and right pointer itself are what? Node. So I will say node left, right? And I will say node right. And in Java, if you do not initialize anything, then by default it's null or zero, right? So int key, and the parameters which you have defined, you have to initialize it also. That is known as constructor initialization. So for that, you will call the function again, same function again, and I will say node. I will say here int, let's say key, int key. If you're using the same name of the parameter, then you have to write this keyword, that this dot key is equals to key, right? So that's, we have defined the node, right? And in the main function, we will make a new node saying that, let's say root is equals to new node, and we'll give a value there. We'll give a value there. So let's make a tree like this. Then its left is 20, its right is 30, and its what? Its left dot right, let's say like this, it is 40, right? So let's make a tree data structure like this. So what we will write, the root node is pointing to 10. Then I will say that root dot left is again as new node 20. I'm writing all this stuff because I'm thinking that you're a pure beginner. You're learning tree for the first time. Then I will say that the root dot right is nothing but new node 30. And what is 40 indicating from root? From root, I have to go left, then I have to go right. Right? So I will say that root dot left dot right is equals to new node 40. Right? Is this okay for you? So great. So let's move ahead. And how to print the nodes? To print the nodes, there are three types of traversal. You can do three types of traversal in the tree. That is in order, that is pre-order, and post-order. In order, in the sense that the traversal is in the form of left, root, and right. Pre-order in the sense the traversal in the form of root, left, and right. Right? And post-order in the sense is that first you have to go left, then you have to go right, then you have to go at root. So how to remember this traversal? I have remembered like this. When you are saying in means inside. So the inside will be root, and the rest of the things will follow order of left and right. Pre-order means pre means first, right? So the first will be the root, and then the rest will follow the order of left to right. Post order means after something, right? Posting after a particular thing. So after the traversal of left and right, it should be root, right? So that's the way I remember it. You can remember it any way you want. So let's get to the coding section now, and we will see. So how these things are working: left, root, in order, pre-order, and post-order. That's not your thing. That's not the point of conversation as of now. If I do this in order in this thing, it would be a traversal. It would give me a traversal, right? Yeah. If I do an in order on this tree, it would give me a 20, 40, 10, 30. If you do not know, then do not worry. In the next lecture, I will give you that how this thing is working, right? So in the today's lecture, the only motto is to see that what is tree, what are the functionalities involved, and what are the subtopics, right? And how a tree is built. Okay, so let's jump back to the coding section. So this is the code I have exactly written for you guys. We have made a class node here which has three parameters: data, the left pointer, and a right pointer, and we have initialized the data using the constructor initialization, right? Then we have a main function. I made a root node as 10. I made a left pointer to 20, a right pointer to 30, and a left right pointer to 40. Everything is happening via the root node. Then I made a function for in-order traversal. If you're not able to understand this function, no problem. I'll explain you in the next lecture. The only motive of this lecture is to understand how the tree is built and how we can verify, right? So the tree is built using these three lines and this structure, right? And I've written an in-order code which will just specify that yes, actually your tree is built in a correct order and you are getting these numbers as your in-order traversal. And if you look at it, this is the exact number which I wrote while dry running this tree, right? So that's it for today's lecture, and I hope we'll meet again. I hope you guys will continue this free lecture and we'll meet again in the next video. And few last things that I'm making this as D sheet, right? So I have completed the recursion video. I have mentioned the links for all the things. Similarly, for the trees, there will be 30 to 35 subtopics in trees, and then we'll jump to BST. So for the first episode, that is introduction and application, I will mention the link here. You can start this what's it, Excel sheet, as well as this will be my DSA repository. Whenever I am doing a code, I'll be pushing it here, right? You can use it for your reference, as well as you can also maintain your own repository. It can give you a track that how much you have learned in journey with me, right? So that's it. So this is the also like you can use this git bash tool. It's very like I use it to push the things there. So I have copied the code there in my SD sheet folder, and then I can use this git bash. I will just say that git status. It will say, yeah, there are some files. Then I will say GA. GA is nothing, stands for git add. I have done some modifications in the script part, and that's why it is accepting. And then I will say git commit. I will say episode 1, right? I will commit it with a message, and then I will just say push it. Git push origin main. I have made a branch as main, as you can see, main. So that's a very handy tool you must learn if you'll be getting in a software industry. Then this is the version control is like one of the most priority thing you must have. So that's it. The code have been pushed. You can refresh this page to verify it. So that is it. Here. This was just the additional information. The original motive was to explain you that how the tree is built, what is tree, right? So in the next lecture, we will first cover all the types of traversal, that is in order, pre-order, post-order, and there's two more traversal, that is level order and Morris traversal. So we'll do that. I'm designing this sheet in an order that will help you in the interviews, right? So in one of the sheets, you will see that Morris traversal is covered. And while I was in the interview, I was asked about this in order. So I mentioned the recursive approach. Then they asked me, can you tell me the iterative one? So I told them the iterative one. Then they were still not satisfied. They tell me to tell the another traversal, Morris traversal, right? Okay. So that's it. Let's meet in the next video. Till then, keep learning, keep growing, and take care. Bye bye.